proof by induction, part 4. Proof by induction that the sum of r cube of natural numbers r equals 1 to n is equal to 1 over 4 n squared times n plus 1 squared. This is adding the sum of cube natural numbers, and example for this will be 1 cube plus 2 cube plus 3 cube plus 4 cube plus all the way to n cube. But say we have a go and do 1 cube. 1 cube is 1, 2 cube is 8, and 3 cube is 27. That's 3 times 3 times 3. Plus 4 cube is 4 times 4, 16. 16 times 4 is 64. And if we add them together, so the sum of the cube of natural numbers, that would be 9. 9 plus 27 is 36. 36 plus 64 is 100. If we then use the same summing for using the formula where n is 4, the largest number here, so we can say 1 over 4, 4 squared into bracket 4 plus 1 squared, and that will be equal to 4 squared over 4 times 5 squared. 4 squared over 4 is 4 times 5 squared is 25, and that equals 100. So we got the same number using the formula for the sum of natural cube numbers, or writing them out individually. So that is what this formula is for. And now we're going to prove by induction that that is equal to that. And the way to do that is to do the first part. We need to show that the statement is true for n equals 1. And to do that, we draw a line here and we look at the left hand side and the right hand side. The left hand side here, which is the sum where n equals 1 and r equals 1 of r cube, which means it's going to be r is going to be 1. So that's 1 cube, and 1 cube is 1. 1 times 1 times 1 is 1. Where we have 1 over 4, n, don't forget n equals 1. So that will be times 1 squared into bracket 1 plus 1 squared. And that equals 1 over 4 times 1 times 2 squared. And that equals 1 over 4 times 1 times 4. And that equals 4 over 4, which equals 1. Therefore, that is the same as that, which means that is correct. For step number 2, we need to assume that the statement is true for n equals k. So if we write the equation again, sum of n, r equals 1, r cube equals 1 over 4 n squared, open bracket n plus 1 squared. We need to transform that using n equals k, so we can now write sum n. Instead of writing n, we write k. K, r equals 1, r cube, which now equals 1 over 4 k squared, open bracket k plus 1 squared. And that's all we need to do. We just need to change the n into k and then change the n here into k. We're going to use this in step 3. Now we're going to use step 2 in step 3 to prove the statement is true for n equals k plus 1. And to start off, we know that the sum of r cube up to n, where r equals 1, is equal to 1 over 4 n squared, open bracket, n plus 1 squared. If I write n equals k plus 1, this is what I'm expecting to get. K plus 1, r equals 1 for r cube. That should give me 1 over 4 k plus 1 squared and k plus 2 squared. Because k plus 1 here, that'll be k plus 2 squared. So this is what I'm expecting. But I'm going to use my step 2 where I have k plus 1, where r cube, r equals 1, is going to be equal to sum of k from r equals 1, r cube, plus the last term, which is k plus 1. I just need to put the cube there because I'm using that. So the last time will be that with k plus 1. And now I need to use the step 2, which is this one, to get that. So this is my goal, and I need to use this from step 2 with the final term here to get this. And to do that, I can start by saying that equals to, I know what step 2 is, that would be 1 over 4 k squared, open bracket, k plus 1 squared, plus the last term, which is k plus 1 cube. There is a common factor, k plus 1 squared, so I can write k plus 1 squared, 1 over 4 k squared, which is that one here, because I've taken that out, plus k plus 1. I'm going to take a quarter out, which means I have to times the square bracket by 4. So k plus 1 squared over 4, and that meant I need to times everything here by 4, so that will be k squared plus 4k plus 4. And that meant if I times this by a quarter, so I get k squared over 4, which is that. If I times that by a quarter, I'll get k 4k over 4. That will give me k, and 4 over 4 will give me 1. So by taking a quarter out means I need to times everything by 4. And now I need to factorize. So I got k plus 1 squared over 4, and I need to factorize that. So if I factorize that, I get k plus 2 times k plus 2. And finally, that will give k plus 1 squared over 4 times k plus 2 squared, which means we get the same value as this one here. So this is where I'm going, and that's exactly what I got here. Using the second step, this one, which is that one, plus the last time, I was able to derive the value if I put k plus 1 here, which is that one, and k plus 1, which makes it k plus 2 squared, and that's what I've just derived using that. Now I can go on to step 4. You must write the 4-point statements to get the full mark. The first one being, since the statement is true for n equals 1, therefore, and if the statement is true for n equals k, which we've shown, then it is true for n equals k plus 1, which we've shown. And finally, the statement must be true for all n greater than 1 or equal to 1. So all these 4 statements has to be written in order to get a full mark.